Welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and in this class we are going to do factorization of polynomials. In the previous session as well, we did factorization of polynomials using factor theorem. In this session as well, we are going to do some more questions on, first we'll do factorization of a quadratic polynomial, obviously using splitting the middle term, and then we'll be doing some questions on the basis of factorization of cubic polynomials using the factor theorem. So are you guys ready? Hello Prince, hi Ajay, hello, hello Shrishti, Naman. Welcome to this session. Are you guys able to hear and see me properly? Am I audible and visible to everybody in this session? Hello Naman, nice joke Naman. Hello Make Coding, welcome to this session. So are you guys ready? Okay, so we are going to do factorization of polynomials. The first thing over here will be a question on the basis of factorization of a quadratic polynomial. So you have studied splitting the middle term. So can you factorize this polynomial and let me know the answer over here? Just do this quickly. I had already discussed factorization of a quadratic polynomial as well as factorization of cubic polynomials in the previous session. Just try doing this thing. Okay, so what do you do in factorization of a quadratic polynomial? The very first thing is, so you have got this thing guys, 4x square plus 8x plus 3. So the very first thing is to multiply these two things in your mind. Obviously you don't need to write it in your answer sheet. I'm explaining, therefore I'm writing it. The first and the last terms, the product of them is 4 3s are 12x square. Now the middle term over here is 8x, right? So you have to break down, you have to split the middle term into two such terms whose product comes out to be equal to 12x square, right? Hello P, welcome to this session. Please write your full name. So this can be written as 6x plus 2x or not guys? The reason being 6x into 2x will be equal to 12x square, right? So you can split the middle term in that manner. So this can be written as 4x square plus 6x plus 2x plus 3 over here, right? So you see we have got two groups. This is the first group, this is the second group. Out of the first group we can take 2x as common. So 2x plus 3 will be left. Out of the second group you can take 1 as common. So 2x plus 3 will be left. I hope this is clear. So out of the whole expression you can take 2x plus 3 as common once again, right? So you can take 2x plus 3 as common and you will be left with 2x plus 1 over here. And that is the factorization of this quadratic polynomial, 2x plus 1, 2x plus 3. So the second option is correct. Is it clear to everybody? Yes, Rajiv, that is correct. It is not like that, Rajiv. I hope it is clear, making coding easier. Yeah, that is a very simple question on the factorization of quadratic polynomial, which we have already done in the previous session. I hope this is clear to every student in this session. Any doubt in this thing, guys? Okay, so let us do factorization of a cubic polynomial now. Can you factorize this polynomial over here guys? 2x cube minus 3x square minus 17x plus 30 over here. Can you factorize this? Yeah, obviously, see I have already explained this in the previous session, but I'll explain it using a factor theorem once again because this is an important thing and I know that many students find it tough to do because like it is time taking, it is a bit complex, right? It is a bit lengthy actually. So the very first thing in this type of question is what? You have to just guess what can be the possible zeros of this polynomial, right? That is the first thing. So suppose the name of this polynomial is p of x, okay? The name of this polynomial is p of x. Now how can you guess the zeros of this polynomial? It's not that you'll put random values in this polynomial by hit and trial that yeah I will put this, I will put that, I will put that. No, it does not work like that. I hope it is clear. Do we have, yeah, you can do middle term splitting over here as well. But see, actually it is the same thing. It is using factor theorem in your mind. You got that or not? What is middle term splitting? It is using factor theorem in your mind if you want to do this, but it makes it complex. So therefore we don't use that method. I hope you understand, making coding easier, right? You can do the middle term splitting, like you can split this one and you can split this one as well. So over here you see 4 terms are there, so it will make it into 6 terms, and then you can make groups of 2 terms each. So it can be done like that as well. No, I'm not doing that because it can be done using this. It is actually the use of factor theorem only, making code easier. That's what I'm saying. It's not a very robust method actually, because many a times you won't be able to think that actually. Maybe in this polynomial you will be able to think that, but if you get a complex polynomial, the methodology cannot be used. I hope you got that logic. Okay. So over here, what is the first thing? How can you predict the zeros of this polynomial? So you see this constant term and you see the coefficient of x cube, right? So constant term divided by coefficient of x cube, isn't it coming out to be 15 over here? It is coming out to be 15. So the possible zeros will be the factors of 15. You got it? Possible zeros will be factors of 15, positive and negative both. So plus minus 1, plus minus 3, plus minus 5 and plus minus 15. These can be the possible zeros of this cubic polynomial. There can be no other possibility for the zero of this polynomial. You got that logic or not? These are the only possible zeros of this cubic polynomial, and that is known as rational root theorem. I had already discussed the logic behind it in the previous session. Something called integral root theorem and something called rational root theorem, that why we are dividing this by this over here and we are talking about the possible zeros like this. I hope it is clear. Now what is your duty? You want to know that out of these values at least one zero you can find. So out of these values only zeros can be there. You cannot have any other value as the zero of this cubic polynomial. I hope it is okay with you guys, right? So can I put p of 1 over here? So let us find p of 1. What is p of 1? You have to put 1 in this polynomial. So let us find the value over here, guys. Plus 30. So I guess this is not equal to 0. This is not 0 because you see this is 30 plus 2, 32, and this is minus 20. So this is not coming out to be 0. So therefore you can say p is equal to x is equal to 1 is not a 0 of this polynomial, right? So let us find p of minus 1 over here. So let us find p of minus 1. In the polynomial we will put x is equal to minus 1. This is a very important thing. Please try to understand that. Okay. So x is equal to minus 1 we will find, and are we getting equal to 0? Let's calculate. This is minus 2 minus 3 and this is coming out to be plus 17 plus 30. I think this is not equal to 0 again. Let us check it once again. So minus 2 minus 3 plus 17 and that is 30. This is not equal to 0 again, right? So it means the other possible zeros can come out of these two. Plus minus 3 over here. So let us find p of 3. Is it coming out to be 0, guys? That's how you can guess it. So p of 3 over here is this into 3 square, and this is coming out to be minus 17 into 3 plus 30. So is it coming out to be 0, guys? So this is basically 54 and this is and this is 30 over here. So what are we getting over here? So I think we are getting 84 and this is coming out to be 78. So that is not coming out to be 0 again. I hope that is correct. You can just check it quickly. We are putting 3 over here. So 27 into 2 is 54. 9 3s are 27, 17 3s are 51 and this is 30. So this is basically 84 minus 78. Yeah, that is not coming out to be equal to 0. Can you give some example for use? See, obviously the use of polynomials is not normally directly used in your real life, right? The reason being, see, it is just a way. अगर तुम ये कह रहे हो कि हर चीज का real life application दो, तो ये कहीं ना कहीं उस चीज को you are deviating from the path actually. See, you are not, there is something called integration. You will study in grade 11. So it is not normally used in your real life. In normal life, it will not be used. But you are studying these things because in a way or the other, these are going to be used in sciences. When you will study, when you will become engineer, architecture, something like that. So these can be used. These will for sure be used. Obviously, it's not that on the basis of this concept only you will make a machine, right or not? A machine or maybe something is made on the basis of different concepts. ऐसा नहीं है कि तुम एक ही चीज को यूज करते हो और कोई चीज बन जाती है. समझ पा रहे हो? I hope you understand that. Okay, so let us talk about other zero over here. Let's find p of minus 3. Are we getting it to be equal to 0? See, I am taking this thing again for you. I know ये थोड़ा सा boring सा होता है, लेकिन I am taking this again for you because this is important, guys. Because you know that this is a bit lengthy, so therefore many students find it complex many a times. Therefore, deliberately I am taking it again for you. So what is this equal to, guys? This will come out to be equal to minus 54, and this will come out to be equal to minus 27, and this is minus 51, and this is coming out to be 30. Now what is this coming out to be, guys? This is, again, you see, this is not coming out to be 0. I hope that is okay with you. This is also not coming out to be 0. You have to check it like this. I am explaining the use of factor theorem, right? That how can you just get which is a possible 0. It's not hit and trial. There is a logic behind that, and that is rational root theorem or integral root theorem. I hope it is clear. Now ये देखो, अब यहाँ पे these two possibilities are there, plus minus 5. So let us talk about that. So the polynomial was p of x over here. So p of 5 is what, guys? Are we getting it to be equal to 0? Let's check it. You know that this question will come of maximum marks. I mean, one of the questions of maximum marks in your school examination, right? So this is 5. I'm checking it for it. Is it coming out to be 0, guys? Let's check it. So this is 250 over here, and this is, and what is this coming out to be, guys? 85, and this is 30. I think this is also not equal to 0. This is also not equal to 0. And see, this is unfortunate basically. It will be plus 51 in case. So yeah, I did not see. In case of minus 3 are you talking about? So yeah, I did not calculate it. We don't need to calculate it because we want 0 now. Dikshit, we want 0 and it was not coming out to be 0. So there is no need of calculating it. Why will you calculate the final value? We want 0. So we will calculate those things only where we are going to get 0. I have just seen that, okay, is it coming out to be 0? No, it is not 0. So I don't need to bother about that. Dikshit, that's what I was telling, that if you will calculate over here, so basically, see, this is minus 54 and this is minus 27. This is correct only. This is plus 51. You're correct over here. This is plus 51 over here. And what we will get, this is 81, and okay, yeah, we are getting that. I did a small calculation mistake. You're right, Dikshit. So it means our work will be done. I did a mistake. It was plus 51 over here. So this is coming out to be, yes, this is coming out to be 81, and that is equal to 0. Correct only. Yeah, that is correct. Exactly. It is giving us 0 only. It is correct. So what does it mean? That we are getting p of minus 3 to be equal to 0. See. So can we say that x is equal to minus 3 is a 0 of this polynomial? Tell me. So x is equal to minus 3 is a 0 of this polynomial. So what does it mean? According to the factor theorem, x plus 3 is a factor of this polynomial. Is it clear? X plus 3 is a factor of this polynomial. Any doubt in that? So if x plus 3 is a factor of this polynomial, can we find the other factors of this polynomial by dividing this polynomial? See. By dividing this polynomial by x plus 3. So you see, we have got this over here. So let us find the other factors of this polynomial over here. So you see this, we are getting over here 2x cubed. So I will get 2x square over here, right? So this will give us 2x cube, and this is 3 into 2, that is 6x square over here. And then we can change the sign. So basically changing sign means nothing. We are just subtracting. See, you change the sign and add, or you subtract. That is the same thing. I hope you understand that. So this is basically 9x square over here. 9x square minus 9x square minus 17x. So I will get minus 9x over here, right? So this will give us minus 9x square, right? So minus 9x square, and this is minus 27x. So just change the sign and add over here. This will get cancelled out. And this will give you plus 10x, right? So this is plus 10x plus 30. So what I can get over here, I'll get 10 over here. I hope this is clear. So this will give you 10x plus 30, and just change the sign and add, you'll get 0. I hope it is clear to everybody. So what does it mean? That this polynomial is coming out to be equal to, this is coming out to be equal to x plus 3 into 2x square minus 9x, 2x square minus 9x plus 10. I hope that is clear to everybody in this session. Any doubt in that? Aisha, that's what I was saying. The shortcut method is the middle term splitting only. In case of factorization of cubic polynomials as well, you can do the middle term splitting. It means this can be splitted into two terms, this can be splitted into two terms. But what will happen that you will not be able to normally think of the possible factors. That's what I'm saying. Maybe after much practice, you will be able to do that. You got that logic or not? Okay, no problem. I hope it is clear. So therefore, you've got this polynomial, and this quadratic polynomial you can easily factorize, yes or no? This can be easily factorized. This is what, guys? This is 2x square minus 9x plus 10. So how can you factorize it over here? Tell me, guys. So you see over here, this is 10 2s are 20. So you have to split the middle term in such a manner that the product of the splitted two terms is equal to 20x square. So you know that 5 4s are 20. So I can write it like this, minus 5x minus 4x plus 10 over here. Is it clear? So this is the first group, this is the second group. Out of the first group, you can take x as common. So 2x minus 5 is left. Out of the second group, you can take minus 2 as common. So 2x minus 5 will be left over here. I hope that is clear. Now out of the whole expression, you can take 2x minus 5 as common, and you will be left with x minus 2. Is it clear to everybody over here? So what you will say that the factorization of this polynomial is coming out to be equal to x plus 3 into 2x minus 5 into x minus 2. That is the answer. Is it clear to every student in this session? Tell me. Any doubt in this? Just confirm in the chat. Hello Harsha, Dikshit, Harsha, 86 pages, P and Aisha. Is it clear? Is it clear to everybody? Rajiv, is it clear to you? So we'll do two questions on the basis of where you don't need to use this factor theorem of cubic polynomial only. We'll do two questions where factor theorem will not be used. I mean, I guess you people are asking that only. Okay, we'll take two questions like that as well. But before that, let us take one more question on the basis of factor theorem. Can we do this one now, guys? So see, most of these questions I'm taking from NCERT and NCERT exemplar only. It's not that, because see, questions like this only, they are going to come in your school examination I'm talking about, right? So what about this, guys? So over here as well, what can be the possible zeros of this polynomial? Those possible zeros will be the factors of this or not, according to the rational root theorem. That is correct or not? According to the integral root theorem, whatever it is, see, you just don't bother about the name of that rational root theorem or integral root theorem. I had explained the logic in the previous class. The reason being, I'll explain once again if you want. Suppose alpha, beta and gamma are the zeros of this polynomial. So obviously this polynomial can be written like this or not? Tell me. X minus alpha, x minus beta, x minus gamma. X minus gamma, yes or no? This polynomial can be written like this. And you see, leading coefficient is 1. This is 1. It means over here as well only 1 is there. Now if you will multiply, if you will open up these brackets over here, can you not say that the last term will be alpha, beta, gamma, minus alpha, beta, gamma, yes or no? You see, the last will be the product of these three or not? So minus alpha, beta, gamma. And if you compare on both the sides, can we not say that this is equal to 20 only? Tell me. Simple logic. This is coming out to be 20. So therefore, the possible values of alpha, beta and gamma can be the factors of 20 or not? Tell me. I mean, you have to just find one zero. One zero if you find, you'll be able to find the other zeros. I did not do that, Prince, because we have converted it into your syllabus channel over here. I hope you understand that. So the possible zeros will be, you can take plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10 and plus minus 20. These are the possible zeros you can think of. I hope that is clear to you guys, right? Now if you see the polynomial over here, you see this is p of x. Suppose just name it to be equal to p of x, right? Now you see there are positive signs only. So first part is very simple, that any positive value cannot be the zero of this polynomial. You got it? Because only positive signs are there, na? So if you will put any positive value in the polynomial will not become equal to 0. It's a simple logic. So there is no need for, in order to check positive values. So let us check negative values only, right? So let us check if p of minus 1 is 0. So this is minus 1 cube plus 13 into minus 1 the whole square plus 32 into minus 1 plus 20 over here, right? So is it coming out to be 0? So over here you see this is minus 1 plus 13 minus 32 plus 20. So this is basically 33 minus 33. So you see, our good luck, the first value is coming out to be equal to 0. This is good luck, you can say. So you can say that x is equal to minus 1 is a 0 of this polynomial, right? X is equal to minus 1 is a 0 of this polynomial. You can easily say this using factor theorem. So if x is equal to minus 1 is a 0 of this polynomial, can we not say that x plus 1 is a factor of this polynomial? Yes or no, guys, tell me. So we can say that x plus 1 is a factor of this polynomial. Okay, so I hope it is clear. So if x plus 1 is a factor of this polynomial, we can find the other factors of this polynomial as well by dividing this polynomial by x plus 1 over here. Right, so let's do this. So we can say we'll get x square over here. So this will give you x cube plus x square. So I can change the sign and add. So this will get cancelled out. So this will give you 12x square plus 32x over here. So over here I can put 12x, guys. So this will give you 12x square plus 12x, and we can change sign and we can add. So this will get cancelled out. So this is 20x plus 20. I hope it is clear. So over here we can put 20, right? So this will give you 20x plus 20. So again you can change sign and this will add and you will get 0 over here. I hope it is clear. So what we can say that this polynomial is coming out to be equal to x plus 1 into x square plus 12x plus 20. X square plus 12x plus 20. I hope this is clear to everybody in this session, right? So this polynomial can be written like this. Now you see this quadratic polynomial you can easily factorize. This quadratic polynomial can be easily factorized because you see if you multiply these two you'll get 20x square and the middle term is 12x, so that can be written as 10x plus 2x. So that's a very simple task. So I can write it like this, 10x plus 2x plus 20 over here. So you see this is the first group and this is the second group over here. So what you will get over here, guys, x plus 1 out of the first group. If you will take x as common, so x plus 10 will be left. Out of the second group, if you take 2 as common, so x plus 10 will be left. Now out of the whole expression, if I take x plus 10 as common, so I'll be left with x plus 2. So this is the required factorized form of this polynomial. Any doubt in this thing, guys? Just confirm in the chat. Is it clear? Harsha, Dikshit, 86 pages, Aisha, Prince, Agam, Rita. Any doubt in this? So that's how you factorize cubic polynomials using factorization theorem. I had taken, I think 2-3 questions we did in the previous session, and in this session as well we have done it. I had explained the rational root theorem and the integral root theorem, and the logic behind that is already explained, that why the possible zeros of this polynomial can be these. I hope you understand that this is not hit and trial. Some must have told to you that by hit and trial you can put the values. No, it is not hit and trial. There is a reason behind that, and that reason is called the rational root theorem or the integral root theorem. I hope it is clear to everybody in this session. Now suppose, okay, this question, this is the same question, guys. You have to factorize the polynomial using factor theorem only. So you can try doing this question and you can write the answer in the comment section after this session. I hope it is okay with you. Now I'll take some more questions on the basis of factorization of cubic polynomials. For example, in this question, so many students were having that doubt. I think Aisha and one more student was having this doubt, that do we every time have to use factor theorem? I mean the long process of factorizing the cubic polynomial. The answer to it is no. For example, you see this question, in this question you don't need to put factor theorem, Factor theorem is not required in this question because you can say it is symmetrical, right? Symmetrical. It can be factorized by taking common factors, right? So if you see the first group, you see this is the first group and this is the second group. Out of the first group, you can take x square as common. So x plus 1 will be left. Out of the second group, you can take minus 4 as common. So x plus 1 will be left, right? So you see over here, we can take x plus 1 as common once again. So we will be left with x square minus 4. I hope that is clear to you. So you see this can be again factorized x square minus 4. It's a simple factorization. This can be written as 2 square over here. So you can use a square minus b square identity, that is a plus b, a minus b. So the factorization of this cubic polynomial is, this is x plus 2 into x minus 2. I hope that is clear. So this can be done many a times. You don't need to use factor theorem every time. I hope that is clear to every student in this session. Okay. So a similar question we can do. For example, you have got this question, and these questions are from NCERT exemplar only. So suppose you have to factorize this cubic polynomial. Again, it is symmetric. That will come with practice. And if you have done factorization properly in grade 8, you see there were many things in factorization when you have done in grade 8, like regrouping the terms and using identities many a times, right? So it makes things very simple. I hope it is clear. So over here, you see two groups are there again, this group and this group. So out of the first group, can I take x square as common? So 3x minus 1 will be left. Out of the second group, I can take minus 1 as common. So again, you see 3x minus 1 will be left. I hope this is clear. Now out of the whole expression, you can take 3x minus 1 as common. You see 3x minus 1 can be taken as common. So you will be left with x square minus 1. So you see again this can be factorized, x square minus 1 can be factorized again. So you see this can be written as x square minus 1 square. So you see I can use a square minus b square identity, and a square minus b square is what? A plus b, a minus b. So this I can write as x plus 1, x minus 1. I hope that is clear. So you see this is the required factorized form of this cubic polynomial. I hope it is clear to every student over here. So it is not compulsory that every time you have to use that long method of factorization. Many a times identities can also be used, but I did not explain identities in these sessions right now. We'll do it in the subsequent sessions, algebraic identities, and obviously we'll be going to practice many questions on the basis of algebraic identities as well in the subsequent 2 sessions over here. So I hope this thing is clear to every student over here. See, one student was asking, can we do this using splitting the middle term? So you see these questions can also be done using splitting the middle term, but what will happen, you have to think, you will not be able to do it readily. You understand that? I mean, you have to think, it will take some time. For example, I'll try to think it over here. I too don't know that, right? And I'll try to fix it in some form over here. And so actually that is also going to be, see, basically I am also using factor theorem only in this case. That's what I was trying to explain to you, that when you do splitting the middle term in case of cubic polynomial, then also you use factor theorem only. Indirectly, you do that in your mind. For example, I know that if I will put x is equal to 1, this will become 0 or not. See, this is 1 cube minus 6 into 1 square plus 11 into 1 minus 6. So this is coming out to be 0 or not. You see 11 plus 1 is 12. So 12 minus 12 is 0. So basically I am doing this in my mind. It means if x is equal to 1 is making this polynomial 0. What does it mean? It means that the common factor must be x minus 1. It means x minus 1 must be the common factor which it can come. So you see, can I write this like this? Minus x square minus 5x square, tell me. This can be written as minus x square minus 5x square. I hope you got that logic. Now in the same manner, 11x can be written as 5x plus 6x or not, tell me. 11x can be written as 5x minus 6x, and minus 6 is already there at last. So what does it mean? You see, this is the first group, this is the second group, and this is the third group. So out of the first group, you can take x square as common. Out of the first group, you can take x square as common. So x minus 1 will be left. Out of the second group, you can take minus 5x as common. So x minus 1 will be left. Out of the third group, you can take 6 as common. So x minus 1 will be left. I hope that is clear. Now out of the whole expression, you can take x minus 1 as common. You see, x minus 1 can be taken as common. So what is left, guys? X square minus 5x plus 6 is left. So you see, haven't we factorized using middle term splitting as well? But what I'm trying to say is this is a simple polynomial. Therefore, you are able to do it. And even if you are using middle term splitting, in case of cubic polynomials, you have to use factor theorem only, because this thing is nothing but a different way of using factor theorem only. You got that logic or not, guys? So you see, now this quadratic polynomial can be easily factorized. You see, this is 3 2s are 6. And this can be written as minus 2x minus 3x. So this can be factorized like this, x minus 2, x minus 3. That's it. So this is the required factorized form of this cubic polynomial. I hope it is clear that cubic polynomials can also be factorized using splitting the middle term. But that's what I am saying, that every time you will not be able to do that if it's a complex polynomial. Is it clear to you, Aisha? Logic is clear, na? We are doing that only. Suppose, for example, I take the previous question. Suppose you got this question over here, right? Wait, there is no space. Wait, I'll take this one, right? So I'll try to think. See, in any manner, I have to think that common. You got that logic, that this I will break into 2 terms, this I will break into 2 terms. So total 6 terms will be there, like this one. I'll show you once again. See, what I did is I had break this into 2, this into 2. So total 6 terms are there, and you are making groups of 2 terms. So in all of them, you must get one factor common. So what does it mean? Thinking of one factor common becomes complex, and that can be done using factor theorem only. Got that logic or not? So over here as well, these are big numbers, so I'll not be able to think immediately that what is happening. Although these are simple only, I think I'll be able to do, because this is looking simple. This is looking simple, you see, you'll get it immediately. And you will say that why you are getting this? Because my goodness, I have practiced many questions. You got that logic? Don't do that, Muzammil, please don't do that. Everybody, oh my God, you're doing that. Don't spam over there. So you see, this is x cube plus 13x square and this. So what I can do, x cube over here, 13x square plus can be written as plus 10x square plus 3x square. I hope you got it. In the same manner, 32 can be written as 30x over here plus 2x and plus 20 is there. You got it? Now what I am doing, you will say that how I have got this logic in my mind. So I have got this logic because I had thought earlier only that x plus 10 will be coming as common, and that will come with practice, guys. Please understand that. So you see, this is the first group, this is the second group, this is the third group. Out of the first group, I can take x square as common. So I'll be getting x plus 10 over here. Out of the second group, I'll take 3x as common. So I'll be getting x plus 10 over here. Out of the third group, I will take 2 as common. So I'll be getting x plus 10 over here. You got that logic? So out of the whole expression, I can take x plus 10 as common, and we will be left with x square plus 3x plus 2. Right? Now factorizing this simple quadratic polynomial is very easy. X square plus 3x plus 2, if you have practiced many questions, you can tell that immediately it will be x plus 1, x plus 2 only. So you see, have we got the same answer? X plus 10, x plus 1, x plus 2. You see, we have got this answer only, x plus 1, x plus 10, x plus 2. You got that logic, guys? So we can factorize cubic polynomials as well using splitting the middle term, and that is the same thing as we are using factor theorem. That's what I'm saying, Shashi Ranjan, it will come with practice. See, I thought in my mind only, there are 2 methods, Shashi. For example, you think about this question, right? So what I thought, I just want 1 0. You got that logic, Shashi? So if I'm putting x is equal to 1 over here, the polynomial is becoming equal to 0. So what does it mean? It means that x is equal to 1 is a 0. So it means that x minus 1 is a factor. You got that logic? It means, Shashi, if I break this and if I break this into 2 terms, so total 6 terms will come. So we will make groups of 2 terms. You got it? 2 term, 2 term, 2 terms. Out of every group, x minus 1 must be common or not? Tell me, Shashi. You got that logic or not? It will come with practice, Shashi. I'm being very honest. It will come with practice. So the same thing I did over here as well. Same thing I did over here as well. I hope it is clear. So you can try doing this question and let me know the answer in the comment section after the class. Although I did it already, but this time I did it using splitting the middle term. You can do this using factor theorem. Do it honestly and comment your answer in the comment section after the class. So that's all we needed to discuss in this class, guys. We'll meet in the next session and we'll be doing algebraic identities on the Infinity Learn class 9 and 10 YouTube channel. Bye bye guys. Take care everybody. See you then in the next class.